rotates with the shaft. A sliding shift sleeve is also driven by this hub, which can be moved back and forth by a selector fork. Forks are connected to sliding rods that are held by the external casing. During gear selection, the fork moves the sleeve towards the desired gear. A blocker ring sits between the sleeve and the gear. The blocker ring's job is to get everything spinning at the same speed and lined up for a synchronization attempt, or block further movement if synchronization isn't possible for whatever reason. The hub has slots for 3 synchronizer keys that spin the blocker ring, but allow enough play so the blocker ring can adjust on the fly as the sleeve teeth approach. The shift sleeve's internal teeth are shaped to push against the keys, which in turn press the blocker ring against the gear. The ring's inside surface is conical and has ridges to engage the cone-shaped gear surface like a miniature clutch. Gradually, the gear begins to spin with the blocker ring. The keys are spring-loaded. Once enough pressing force builds, the keys are no longer needed and move down and out of the way, allowing the sleeve to progress into its final synchronized position with gear locking teeth. This process enables fast gear selection between rotating components while keeping main gear teeth safe from the change procedure. Locking teeth on the sleeve and gear are slightly angled in some designs, encouraging a more secure connection. Now, power flows through the splined hub and sleeve, through the gear set, and out of the transmission. To switch gears, the clutch is pressed in, pressure is relieved, and the sleeve can slide into synchronization with an adjacent floating gear. Since each sleeve can only slide between adjacent gears, for this 6-speed transmission there are 3 selector forks and rods. The first and second floating gears operate from the output shaft, but this doesn't fundamentally change functionality in any way. Forks and rods only move back and forth, as directed by the shift change assembly. This component can swing side to side to select a specific rod and fork. And once selected, a metal tab pushes the fork one way or the other. Let's trace this component's movement from the shift lever itself. The shift lever rides on a ball that allows movement on 2 axes. Each movement axis is separated into its own cable. These work something like bicycle brake cables to translate stick movement to the transmission. At the other end, cables are attached to a rod that protrudes out of the transmission case. This rod can move up and down or rotate based on distinct cable input. A specially designed piece at the other end of this rod moves connected components to swing side to side or slide the metal tab back and forth. Reverse gear. The reverse gear has its own rod and selector fork. The transmission must come to a complete stop to shift into reverse as there are no synchronization components. Adding the third idler gear to the system reverses final output. Neutral. When in the neutral position with no gears selected and the clutch engaged, meaning the clutch pedal is not pressed in, the transmission input shaft spins, but since no gear is synchronized, no power flows out of the transmission. Oil. oil rests at the bottom of the case and is splashed up onto gears for lubrication. There's no oil pump or filter.